So this presentation will also be recorded, so if anyone wants to check it out, it'll be available later on in the afternoon on YouTube. And for those of you that don't know me, my name is Alex Worsfold. I've been with MCAD for a little over a year now. I'm a certified SolidWorks professional. I'm also certified on training and support. And what we're going to be talking about today is some assembly tips and tricks. And the agenda here, first of all, we're going to take a look at performance and what kinds of things affect performance on the machine and also in SolidWorks. We'll also talk about configurations. We'll talk about speed pack, lightweight parts, large assembly mode, large design review. All right, so the first thing here is performance. So what kinds of things affect performance? Does anyone want to take a poll here? So there's a little quick poll here. So what, go ahead and choose one. What do you think affects performance most? So let everyone go ahead and vote on that. Looks like about 50% of you, 75% of you so far. All right, so everyone's voted, so let's take a look at that. So it looks like about 38% of you said that hardware is what affects computer, and about 60% of you said that users affect performance, and that's pretty much the average there. So about 30% has to do with maybe SolidWorks and the hardware, and about 60% of that is going to be attributed to how you build your parts and how you create your design. So, what kinds of things can you control? So the first thing is obviously just in general settings here in SolidWorks. So there's I pointed out a couple of settings here under Tools, Options, Performance. So those three settings are probably going to get you the biggest bang for your buck just right at the beginning. Verification on rebuild. This is an advanced body checking. It allows it to see if there's any issues with surfaces or edges. And actually, I need to hide that poll there. There we go. Sorry about that, guys. So again, just like you guys said, about 30% of the of you responded with SolidWorks and hardware, and 70% said user control. Lightweight components. This option here, you're going to want to turn that on almost automatically. And the reason for that being, when you create or when you load an assembly, you don't want to be loading all of that extra data for lightweight components. So this right here, that option will be, again, a huge time saver. And also the no preview during open. So as you go to open an assembly, you're going to see it right away. That actually takes a little bit of time to generate, and keep that on the screen while it's trying to open the rest of the parts in the background. So those kinds of things, turn off no preview during open, turn off verification on rebuild, and turn on lightweight. It's going to help you save some time. So other things that you can control are your hardware. Obviously, buying new hardware if it's out of date. How you build your parts can also affect that performance. Also, how you manage your assemblies can affect the performance, and also just the environment that's on your computer. So we'll talk about some of these here. So the first thing I wanted to get into is hardware. So 32-bit or 64-bit, what's the difference here? And the difference really is the amount of memory that it can use. And 32-bit is limited to about 2 gigabytes per application. 64-bit is theoretically it's limited to about 8 terabytes per application. Now we're not quite there yet in in the development of that. Windows or Microsoft is still working on getting there, but you can see that the limit, the amount of RAM that Windows will actually take advantage of, is significantly higher with 64-bit platforms. And with that, RAM that's the most important thing when you're working with large assemblies and trying to get performance out of the computer. Next most important thing is multiple processors, or just your processor in general. And in general, multi-threading or multiple processors is not going to have a ton of effect in SolidWorks, and the reason for that is there's only a few things that are multi-threaded. For example, photo view. If you do a lot of photo rendering, then having multiple cores and having multiple processors will definitely benefit you. As soon as you start a rendering, you'll see the processor peg all the way. That's it's using all of the available processing power. Same thing with simulation. Simulation will use most of the processor during certain stages in the analysis. File translation, again, can take advantage of that. Even drawings in SolidWorks take advantage of that. It actually calculates the hidden lines in the background as it's displaying or as you're using the drawing. Another thing that can affect your performance is your video card. So if you use multiple monitors, you're going to want to have more RAM on that video card, or more video memory on the video card. So if you use multiple monitors, or if you use a really high resolution, if it's starting to slow down, you may want to think about upgrading and getting more video memory. And then, of course, just having it be a certified card, something that is capable of displaying everything that SolidWorks needs to display. You want to check that out on the SolidWorks website. So if you go to the System Requirements page, there is a section for graphics that you can take a look at. And another thing that can affect performance is service packs. Now, service packs don't always affect that performance. There's, throughout the last couple of years, there's maybe been only a couple of service packs that really affect that. But it is something that that can make a difference. So, good design practice. And the question is here, should I create top-down design, or should I build components that are from the bottom up? So top-down meaning that those are built around other components within the assembly, or bottom-up meaning I've created them separate, just by themselves, and then I've inserted them into the assembly. So, if you need to use top-down design in your assembly, it should never be placed into the top level of a large assembly. And the reason for that is it has to solve every time you rebuild or every time you move a component. Okay, so those kinds of things are going to drive up the amount of time that it takes for a rebuild, or just to navigate through the assembly. So if you need to do that, maybe put it in a smaller subassembly. And the reason for that being, at the top level, that subassembly is solved as a part. So it doesn't take any additional resources to try to calculate that. Okay, assembly layout sketches can also help you manage what's going on in your assembly. For example, large plant design, you may have a layout that determines where components in the plant are at. And so by modifying that one layout sketch, you can drive where those pieces are sitting on the floor. Same thing with machines. If you need to develop maybe some kind of complex mechanism, You can use a layout sketch to do that. And we're just mentioning it here now, but I'm going to show another example in a bit here. Another option might be a base part or a master model technique. These work great for consumer products, things like peripherals for your computer, like a mouse or maybe the speakers that might be sitting next to your computer. Anytime you've got complex shapes, sweeping surfaces, if those need to to match from maybe one half of a part or of a product to another, maybe they're screwed together. If you need those surfaces to match, base part can help you accomplish that. And then also flexible subassemblies. And I'm not sure if everyone is aware of this, but if you've got maybe a smaller subassembly and you wanted maybe some of those parts in that subassembly to move, there is an option called flexible, and it's in the component properties. And I don't suggest leaving this on, and the reason for that is it needs to solve the location of every one of those parts in the subassembly or in the main assembly every time you rebuild. So turn it on when you need it, move it around, make sure that your mechanism works correctly, and then turn it off. You don't want to leave it on. Okay, so how do assemblies solve? So if you've got a large assembly, this is the order in which everything solves. So the first thing that happens, all the parts get placed. So that's done, or sorry, all the parts get rebuilt. So if any of the parts have been changed, any of the features have been changed, then that needs to happen first. So parts need to be up to date first. Next thing that happens is mates. So once those parts have been rebuilt, parts get placed by a mate, and then those parts can be patterned. And then any cuts that you might have at the assembly level. So if you've got a cut that needed to cut through multiple components, those components would need to be placed first before that would happen. Okay, and the same thing with in-context relationships. So if I've got maybe a component that needs to change in size around the rest of the parts, that won't happen until the rest of the stuff earlier happens. So if you if you needed to update that component, it might have to go through a second rebuild before that component is fully up to date. Okay, or maybe I have a part that's mated to another component of a pattern. So the position of that secondary mated component wouldn't update until after my pattern was updated. And so these kinds of things you can get into multiple rebuilds. So you might have seen this happen in the past with one of your assemblies. If you hit rebuild once, some things change and update, but not everything is in the right position yet. And you might have some rebuild flags on some of your parts. So that means that maybe the order of some of the things that you're creating is out of order. So you may want to look into that. And then after all of that, then it's fully rebuilt and it's finished. Okay. Now there's a tool here to help us take a look at these complex relationships, and that's called the Assembly Expert. So I'm going to pop back into SolidWorks here and show you guys just a little bit about that. So I'm going to open up an assembly that I've created here. Now I'm opening this up fully resolved, just so you guys can see, roughly how long it takes. I think there's about, I know there's over 300 bodies in this assembly here. So if we take a look at assembly statistics or assembly experts, so we can take a look at, SolidWorks is looking at really what's going on in this assembly. So it tells us all the files have been updated. Now if maybe some of these files had not been updated yet, then there would be a second button down here that I could click on and see exactly which parts needed to be updated. Total number of components. It tells us right here that large assembly is turned off. And then it gives us some statistics here. Okay, so this can really help you figure out, how deep you're going, how many sub-assemblies you have. It would also tell you if there's, in-context relationships. It would tell you if those are, if those needed to be, what's the word? If those needed to be maybe looked into. All right, keeping your computer clean. In the past, this used to be a manual process, but now in the SolidWorks RX tool, there's a one-button cleanup. So, and you can uncheck these options here. So if you don't want it to clean out the temporary internet folders, you can just uncheck that before you run this. But it will also do, a scan on your hard drive, so it'll check the health of the drive and make sure that there's no errors on it. And also the Windows defragmenter. The defragmenter isn't really as important as it used to be, simply because Windows does that automatically now. It's right out of the box with Vista and Windows 7. It automatically does a defrag now. All right, so the next section I wanted to cover here is talking about configurations and SpeedPack. SpeedPack are a part of configurations, and then also we'll take a look at lightweight parts and how that might affect speeding up opening. So with configurations, there's a new feature here. There's a new rebuild and save mark in 2013. And really what that's going to allow you to do is open those components faster when you're placing them in an assembly. So if you've got a part that's got multiple configurations, you can add this little icon here so that it saves it to the component. So that whenever I need to bring that into the assembly, I choose the configuration and I don't have to wait for it to rebuild before it places it into my assembly. The downside to this is it's a bigger file size. So the more configurations you have and the more that you've saved in that component, the bigger the file size is going to be in Windows. And later on in the future, if you decide that you don't want to save all that data, there is an option. If you right-click at the top level of the configuration manager, you can purge all of that data from those configurations. So best practices with configurations here. I suggest creating simplified versions of components. And one way to keep it consistent is to save it with the template. So, in a previous life, I used to create a template that had a default configuration and a simplified configuration. And the reason for doing it in the template is that way my names are consistent. So I always have a configuration here called simplified. And even if it's just a few features that I needed to suppress just to keep it simple, it does go a long ways, especially when all those parts start to add up in the main assembly. And whenever you need more speed out of your assembly or need to be able to work with it faster, it's really quick to create a simplified version of that assembly. I could just select multiple components, and then with all of those parts selected, if I have one configuration in there that's consistent across all the parts, then it'll show up there in that list. So I could easily create a simplified representation of my assembly with just a few quick clicks. SpeedPack. So what is SpeedPack going to do for you? Basically, it's a way to simplify your assemblies without suppressing components. These are going to be most noticeable in very large assemblies, very complex assemblies. But what it does is it takes out a lot of the data, a lot of the graphical data, and doesn't load it. So you still use, or sorry, it doesn't remove the graphical data. It removes a subset of the data in the background that's loaded into RAM. So you have the ability to choose which details you want to save. All right, so let's take a look at SpeedPack and how we can use this. So again, I'm going to switch back into SolidWorks here, and we'll take a look at these wheels and tires here. So I'm going to go ahead and open one of these here. And having technical difficulties, here we go. So I'm going to open up this wheel and tire assembly here. And I want to create a SpeedPack configuration of this because I don't need to use all of these surfaces whenever I bring it into my main assembly. So right here from the configuration, I can add a SpeedPack. And then from here I can choose which faces I want to use. So these faces that I'm picking, these are what a user would be able to use to mate it to the assembly. So I want to pick the faces from the hub. I want to be able to mate the hub to maybe my steering knuckle or to the axle. Maybe I also want to be able to take a measurement from the back side of the rotor, maybe the back side of the caliper. Maybe wheel clearance is an issue, so I could go ahead and select maybe a face from the wheel here. Maybe the front edge here as well. So I'll go ahead and pick this face, those faces there. So once I'm done, I can apply that. And once it's done, we'll get a ghosting effect. So as I move my cursor over the part, you can see most of the surfaces are now gone. They're really not even in the model anymore. And then these surfaces in the background, I would be able to use those to add mates to or take measurements from. Okay. Now this ghosting effect, not everyone likes this effect, so there is an option here. If we go in and look at SpeedPack, so right here under System Options, Display Selection, so Display SpeedPack Graphics Circle. So if we don't want to see that, we can just turn that off, and so now it'll look just like a regular component, except we get a little mark there next to the cursor that just lets us know that that is a SpeedPack part. Okay, and just like a configuration, I can choose to use it or not. So if I double click on a different configuration, now I'm using a full configuration or full part, and you can see that SpeedPack mode has been saved in the configuration for this assembly. Okay, so very quick and easy way to help reduce some time, especially on really large assemblies. Okay. The other thing that SpeedPack can do is it'll help facilitate file sharing. So if you want to, if you've got maybe this wheel and tire assembly that you wanted to send to one of your customers to use in their assemblies, there would be no need to send all of the parts. You could send just the assembly file. You don't need to send all of those components. They'd still be able to mate this up within their assembly. Now the only downside to this is that it doesn't work in all scenarios. For example, photo rendering. I can't photo render a SpeedPack assembly. Same thing with simulation. Essentially what SpeedPack is doing is it's removing that data from the assembly or from the part, so it wouldn't be there for an assembly. So you need to not have that on. Lightweight mode. Okay, everyone should be using lightweight mode. Essentially, the time that it takes to open and then resolve from lightweight is actually less time than to open a fully resolved assembly. And I've done a number of tests on this, and almost every single time the amount of time is less to open it lightweight first, then fully resolve the components if I really wanted to do that. Okay. Also, when you're in lightweight mode, the amount of time that it takes to rebuild the assembly is less, and again, that comes back to there being less model data in the parts. So essentially what happens here in lightweight mode is only a subset of the graphical data is used, and anything remaining is only going to be there when you click on it. So let's take a look at that. All right, so I've got a large assembly here that we're going to, or a medium-sized assembly that we're going to open up. And you can see here when I go to open this, there's a mode down here in the bottom of the window. So this mode right now, SolidWorks has automatically triggered large assembly mode. It knows based on the number of components. We're going to talk about this a little bit later, but it knows that it should be opened in large assembly mode. I'm going to go ahead and open this fully resolved, and I want to show you guys how long it takes to open this assembly. There's about 1,000 parts in here. And I guess while this is opening, and you can see it's pretty much open right now. If you guys wanted to look at the specs on my computer here, so I've only got 8 gigs of RAM, and I've got an i7 with about 2.8 gigahertz. Okay, so that didn't open up too bad. But let's take a look at how long it would open if I used large assembly mode. So we'll go ahead and grab the same assembly again, and this time we'll do lightweight. Let's take a look at how long that takes. And we're done. So a lot faster to load. Essentially, what you're going to see in the feature manager is you're going to see these little icons over the parts. There's no feature data there until I actually go to do something with it. So if I need to modify this part, I can edit that part, and now all those features show up. Okay, so it's there on demand. Okay. So there's a couple other things. I can still show edges of the part and things like this. But let's take a look at large assembly mode as well. So again, same assembly. Open it up, large assembly mode. And again, it's very fast. One of the differences here is some of the graphical detail has been toned down a little bit to make it faster. And there are options that you can set for large assembly mode. So for large assemblies, you can have this automatically turn on when you reach a certain number of components. And when large assembly mode is active, it turns these specific options on or off. So in lightweight mode, what can you do? And the answer is pretty much everything. And then again, for large assembly mode, Essentially, it's a collection of settings that's going to help you improve assembly performance. It can be automatic based on a number of parts. Okay, talked about the options. But there's one more mode of working that I wanted to talk about, which is large design review. And it's a little bit more limited. You can also just open just the assembly in large design review, but you'd still have access to the feature manager. You'd be able to see what parts there are. You'd still take measurements, cross sections, hide components, but there's a second mode here called walkthrough. So let's talk about large design review. So again, another mode of opening here. Okay, and you can see that that opens up much quicker than either large assembly mode or lightweight mode. Again, we're limited on the feature manager here. We can only see certain parts, or we can only see certain things. You notice that the mate section is gone. I can still see every part. It is linked together, so if I click on a part, it's going to highlight in the feature manager here. Okay. But you'll notice there's this option here for walkthrough. So I can start a walkthrough. It's essentially turning SolidWorks into a little bit of a game here. So I would be able to walk around my assembly here. I can save animations of this. And again, I would just need the assembly to be able to open this. By the way, with the large design review, I'm going to go back to this here. So let's go back to large design review. There's one other thing I wanted to mention, and that's if you need to modify components, you can still do that. So for example, I don't have access to this, but I can still open the part. So I can open it and make changes. Any changes here will get propagated back to the assembly and update the mode here. But again, if you send that to someone, they wouldn't have that capability unless you send all of the parts and assemblies with it. All right, so the next section here, assembly layouts. So essentially this is a sketch in the assembly, and we can use this assembly to, or the sketch to help create components. We can use it to help develop complex mechanisms, and we do it through blocks. So we could sketch out an object, and then we could save that as a block, or I can insert any other block off of my computer. Okay, and I'd be able to, I can also use those to place components in the assembly. Right, I can build components off of it. Another thing that I can do is I can actually animate the sketch. Okay, so if you have SolidWorks Office or SolidWorks Professional, part of that is an animation, so I could keyframe an animation of those sketches moving, which I've done here. I don't know how fast that is going to show up over the webinar there, but if you need to create complex mechanisms and need to lay it out quickly, it's a great way to do that. So essentially the way this works is there's a tab here for layout, so you can edit the layout of the assembly. So here you can see I've got a number of different blocks, and then I have a couple of dimensions that are restraining the lengths of these cylinders. But if I turn those off, I'll just turn these to driven here for a second, so that I'll be able to move these components around. But you can see as I drag the sketch, all of those blocks are going to react to their individual constraints, to those sketch restraints, right? So you can see I've got a number of constraints that are holding things in place there. And then later on, if we decide to turn, one of these parts into a component, so for example, maybe this part, if I want to make a component out of this, I could say make part from block. Okay, I can either use the block directly or use the block as part of the project. Okay, so there you can see it started a new component here. Started a sketch with that same block. If I open this up, let's see, it's just a part with just that one block. I could do anything that I want with this. I could extrude it, add more features to it. But the nice thing about this, it's still going to remain in position here in the assembly, and it'll still move with the rest of the sketch blocks. Okay, so a great way to develop complex mechanisms. All right, so the last section here is envelopes and advanced selection techniques. So let's take a look at that. So envelopes are great for part selection. So it's a special type of component that's ignored in the BOM and also in mass calculations. You can copy them, you can mirror them, pattern them. Any of those copies also become envelopes. Other uses, you might use it to reference, as a reference of other parts. Maybe they're purchased parts, but you don't want them to show up in the BOM. You'd be able to take measurements from that envelope. And again, it doesn't affect the mass of the main assembly. And then you can also use it as a selection tool. So I'll show that here just real briefly. Any part can actually be used for an envelope here. So all I'm going to do here real quick is I'm just going to start a brand new component. So I'm going to insert a new part, and I'll just start that on the right side plane here. I'll just sketch that out real fast. All right, so now I've got this big cube in here. I want to turn this into an envelope. So it's under the component properties. There's a little check mark here for envelope. And you can change the color, the default color of these envelopes. It's now a new part here in the tree. It's going to give you a different looking icon. And with that, I can do certain things. So for example, if I right click on this part, I can come down here to envelope, and I can select using an envelope. So if I want to select anything that is completely inside the envelope, okay, so it only selected the components that were completely inside. Or I can and say only anything that crosses that envelope. So it's only going to select the components that are intersecting the envelope, but not completely inside, not completely outside. Okay, so now that I've got them selected, what can I do with them? Well, I could suppress them, I could hide them, I could delete them, right? I could change all their colors. I could isolate them, so if I just want to see just those parts that I had intersecting that, right? So I could maybe save this as a display state. There's all kinds of uses that I could use with envelopes. You know, maybe I'm working on a large airplane, and I need to route a bunch of wires through, you know, hundreds of bulkheads. I could create one wire or one part that intersects all of those bulkheads, and then isolate the components that I know that I'm gonna need to create a cut in order to get, you know, a set of wires through each one of those bulkhead parts. So there's all kinds of things that we could use those for. And then the last section here is advanced component selection. So it's a way to select components based on characteristics of the parts. So maybe mass, volume, names of configurations, or custom properties. I could select based on document name, whether it's resolved or not, whether it's lightweight or been suppressed, or maybe any parts that have errors. Okay, so there's a ton of things that we can select based on this. So advanced selection, we can come over here to the configuration manager. I can right click on a configuration and advanced select. And so from here I can define my own criteria. So maybe I want to, you know, look for part, custom property, maybe description, and I want to find anything that contains the word bulb. Okay, so there you can see it selected the part. If I wasn't sure, you know, where that was at, I could isolate. There's the component that I was looking for. Okay, but those search criteria can also be saved. Okay, so you can import or manage searches, previous searches. All right, guys. So hopefully we went a little bit over time here by about 20 minutes or so, but hopefully everyone got something out of the webinar here. So again, remember, most of what affects performance is things that we do as users. So you want to keep those as impact, you know, as low of an impact as possible. So through simplification, through lightweight, there's all kinds of different things that you can do. So if anyone has any questions, I can go ahead and answer those now. And looks like there is a couple of questions here. So let's see, it looks like Jennifer asked, are there any inner part dependencies from that capping machine? And I think there are a few in that one. You can take a look at it and use our assembly statistics to figure that out. So let's see, we'll go back to webinars here. And we'll go ahead and open this resolved. Jennifer also asked, are the block sketches related to the original block sketch? Actually, each one of those blocks are separate entities. So you'd be able to lock and break references in each one of those individual blocks. All right, so looking back here on Assembly Expert, looks like doesn't look like there are any interdependencies on this assembly. So if anyone has any other questions, I'll also go ahead and stick around. Thanks, guys.